an update. Some of you might remember that about a year ago, I was pretty down because we had just found out that we had been turned down for telescope time requests to look for exomoons using JWST. And to me, this was pretty depressing because we had just spent the previous year doing all these calculations, trying simulations with different telescope settings, and the conclusion was that if we want to find the moons that are in our solar system, things like the Moon, Titan, Ganymede, Callisto, those kind of small moons, JWST was the only chance we had. Even Hubble could not do it, let alone Kepler or TESS. So when we got turned down, that was a whole year where we were going to have basically no shot of finding those moons. And I was kind of worried. To me, it kind of signaled that maybe we just wouldn't get time. Maybe this subject area just wasn't, for whatever reason, attractive enough to committees to get selected for that prestigious and very rare telescope time, heavily oversubscribed. So it's been a year. We put in another proposal, in fact, 3 more proposals. And frankly, a lot of that was due to your encouragement. Many of you in the comments said, look, you have to keep going with this. Please do resubmit. We're all rooting for you. There's also bad comments in there as well, but whatever, it's YouTube. But the good comments, they really do make a difference to me. I do read them, and I know Ben was impacted by those as well. And so I think we felt, look, we have to keep trying. We're going to give this another shot. And it turned out that there were even better candidates to go for this time around than last time. So we put in 3 proposals, 3 planets that we wanted to go after to look for exomoons. And we can also do some other cool science as well. But obviously exomoons was a thing that I was really hoping that we'd get the time to do. Now, of these 3, I have to say one of them really stuck out to me as the best target because it only transits every 1,067 days, I think it is. It's on a very long period, so almost 3 years or something it takes to go around its star. And so in cycle 2 and cycle 1, the previous 2 years, this object wasn't even available to us to go after. Cycle 3 was its opportunity, and we'd have to wait another 3 years later. So it'd be like cycle 6 or 7 or whatever until the next one where we'd get another shot. So this felt like a special opportunity. And this was by far our best exomoon target. If we didn't get this one, it looked really grim for the future. So this was kind of like even more riding on it for me, at least in a kind of mental sense. So when I was teaching class this morning, I went into a classroom just across the corridor, set up my laptop, set up the projector, and I knew the news would probably come through today in an email. And there was kind of rumors on Twitter of that happening. And so I saw, just as I was, warming up the projector, little ding, the Apple notification. I could just see the beginning of the email, and it said, "We are pleased to inform you." That's all I saw. And I couldn't quite believe it when I saw that. It was a pretty amazing moment. I really had to stop preparing for class and stop class and just read the email and just zone in on what was happening. And I guess I was like, is this, your mind always wonders, is this some kind of cruel joke? We are pleased to inform you you did not get telescope time. But no, it said, we are pleased to inform you that we've given you telescope time. And it was our favorite one of those 3. So this is Kepler 167e. It is a planet which actually I discovered years ago. So it kind of feels like poetic justice somehow that this is the planet that we get to go after, a planet which I found. And this is probably the most Jupiter-like exoplanet that we have seen transit another star. It is pretty much the same radius as Jupiter. I think it's 92% the radius of Jupiter. It's been confirmed recently to be just 1% more massive than Jupiter, so basically identical to Jupiter's mass. It orbits a K-dwarf star on this basically 2 AU orbit, so twice the Earth-Sun separation, almost at Earth-Moon separation then, Earth-Sun separation, and that means it's very cold. So its temperature is something like 130 Kelvin or something, which is kind of comparable to Jupiter. It also has 3 planets on the inside, likely rocky planets or mini Neptunes. So this really does look like a kind of solar system analog, just maybe slightly squeezed down because it's a K-dwarf rather than a sun-like star. But everything here looks perfect. And so if there's any chance of any planet showing exomoons or having exomoons, it would be this planet. And so I was convinced that it both should have them, and also we could show in the proposal that we had a 90% recovery rate. I think it was 93% recovery rate of a Jupiter-like moon system. So take Jupiter's moons, put them around this planet, and 93% of the time, it sort of depends on their exact orientations and their phases and things like this, but 93% of the time, we would confidently detect them with JWST in our simulated data. So I guess the committee was also excited about that, and they've given us the time. We were nervous we wouldn't get time because we were asking for a lot of telescope time. I think in total it was about 59 and a bit hours, so almost 60 hours of telescope time. And on top of that, there's overhead, which pushes it over 3 days. So, 3 days of JWST pointing at this one thing, looking for a tiny blip of a possible exomoon signature that could be there. And by the way, we have no hint of an exomoon yet around this object. This is a blind search, but it's a blind search where we think the odds are just really good because of the type of planet that we're picking. But it is kind of terrifying to ask for so much telescope time. It's unusual. Most requests that have been accepted for exoplanets are typically like 20 hours, maybe 10 hours, 15 hours. And that's normal, but to ask for this amount of time, it's a lot. And so in a way, your science case has to kind of be like 6 times better, I suppose, than those ones which are asking for 6 times less data. So it's always going to be a really hard ask. And so that's why I'm particularly thrilled. I think yesterday I was on the Discord with some of the guys, the Cool World supporters who are supporting what we do. And I was saying, I'm apprehensive. Like, I'm not feeling good about this. And in group meeting, which we had on Wednesday as well, the day before, Ben was here and we were looking at each other and we were like, it's not going to happen. We just have to, let's just accept it's not going to happen and just try. And I was thinking, God, I'm going to come on, I have to update you guys. I'm going to have to come onto YouTube, tell you guys what happened. And it's going to be really hard to do that because I know so many of you are really hoping for our success. I was like thinking, how am I going to do that? And so the fact that I don't have to do that and I get to tell you this good news is amazing. So I'm thrilled. We'll speak much more about this planet in future videos. That's just maybe all there is to say today. It's just the immediate reaction of how happy I am. But look, I've been there, and if there are astronomers watching, or any of you watching who've been rejected for something recently, whatever it is, whether it's JWST time or a job or a loan, I don't know, whatever it is, it can be pretty crushing. Trust me, I know. I've been through that many, many, many times, and I think that was pretty obvious from the last time I spoke about this on the channel. But look, you have to persist, and it feels like fairyland, like magic land, that you'll ever get accepted. It felt like a fantasy yesterday, and I was convinced it just wouldn't happen. And it's real. It's happening. And I don't want to tell you, it's so cliche, but you just have to keep going. You have to keep pushing. And the moment you stop is the moment you guarantee that you will not succeed. It's all about just persisting. And actually through that persistence, I do think you improve. I think you become better and stronger, not just mentally, but actually we fine-tuned our case from last year to this year. It is undoubtedly a better scientific case. So we're very excited. The other 2 proposals, they didn't get accepted, but they were very well ranked. And so that actually bodes really well for the future as well. So I think the future is bright. In fact, there is even another team which got time to look for an exomoon as well over at Harvard. So we're pretty excited about that. There's another team that's going to be doing this, not for a totally different target, I assume. We don't even know what target it is, but it's a much, much smaller telescope request. So I'm guessing it's probably an M-dwarf. We'll see how that shakes out when we see the abstract. But look, the fact is the community have heard us, right? They've heard you, they've heard me, they've heard everyone who wants us to start finding these exomoons. And they are now, for the first time, JWST will search for these things. And it is undoubtedly capable of finding the kinds of moons in our solar system around planets that are very similar to the ones in our solar system. So I don't know what to tell you. This is it. This is the start of something really special. And for all of you who've been with us on this journey, thank you so much. And stay awesome, stay curious, stay thoughtful. did that in the wrong way, but you know what I mean. See you out there.